All right, so welcome back to OneClass. My name is Joey. I'm going to be your math teacher for this session. If you're tuning in for the first time, thank you so much for watching. What we're doing here at OneClass is that we are providing unique online lessons and basically live streams and videos of teachers generating solutions for our students at home. We know due to the COVID-19 situation, there are a lot of school closures and schools basically closing indefinitely. So what we're doing here is at OneClass, we're trying to keep you on top of your studies, and we are basically making these videos for you to, for us teachers at OneClass to basically teach you concepts that you most likely will learn at school. And these contain subjects in the secondary school level and the university and the college level in both the subjects of mathematics and also in chemistry as well. So a little bit about myself. My name is Joey. I'm currently a secondary school educator in Ontario, and my teachable subjects are chemistry and music. However, I am planning to get my teachable in math further down the road once school opens up again. So with that being said, I did stream a bit earlier, and we did problems with kind of grade 9 math and grade 8 to 9 math in terms of pre-algebra, algebra 1, and geometry. So what we're going to do today is for the next hour, I picked problems that you would typically find in algebra 2 or pre-calculus situations. So kind of grade 11 and grade 12 math here. So without further ado, let's get started on these problems for today. All right, so we have here, it says, according to the fundamental theorem of algebra, which polynomial function has exactly 11 roots? So we're looking for a polynomial function that has 11 roots. So polynomial. So when we say it has 11 roots, we can also say it has 11 x-intercepts or 11 solutions to the polynomial. So let's look at A here. And A here is x minus 2, and then x plus 2 to the power of 11 here. And basically, when we have this polynomial function, we can basically say that the maximum amount of the maximum amount of roots that exist in a polynomial function is basically the highest degree. So when we're multiplying exponents, remember we have this. You can think of this as x minus 2 has a degree of 1 here. When we multiply 1 by 11 here, we're going to add our exponents, right? Every time we're multiplying exponents, we can simply just add the exponent numbers here. So we have imaginary 1 here. You can think of it this is that. So we have 1 plus 11 here, which means we have here, this would be 12 roots, right? Or 12, the 12 is the highest degree here. So we can say maybe I'll write down 12th degree here. This is 12th degree, which means we have, if we're in the 12th degree, this means we have 12 roots in our solution, right? So we have 12 solutions, or we have 12 roots here, so, or 12 roots here. We're looking for 11 roots. So this here is the incorrect answer. So A would not be the correct answer here. We can look at B here. B would state that we have x, this is x cubed plus 3x squared plus 3x squared plus 2 to the power of 4 here. And then whenever we're taking anything to the power of 4, again, we have an exponent within an exponent. We're going to multiply our exponents, right? So let's look at it within the bracket here. We have a cubic function, x cubed plus 3x squared plus 2 here, which means the highest degree we can ever get, it would be a x cubed here to the power of 4. Whenever we're, again, taking the exponent by the exponent, we are multiplying exponents, right? So 3 times 4 here would give me 12 again. And again, we would have the 12th degree. So in the 12th degree here, this would be 12 roots again. So this here would not be our solution here because we are looking for 11 roots, right? So this here is in the incorrect solution here. Let's look at C. C would give us x squared. So it's x squared plus 1 cubed times x to the 5 plus 9x cubed plus 4x squared plus 16x, right? So looking at this function here, we have x squared plus 1 cubed, right? In this case, we can rewrite this as, okay, I have the exponent with the exponent, I'm multiplying exponents. So x squared times 3. So 2 times 3 here would give me an exponent of 6 here in this case. And then 6 here I'm going to multiply that. If I'm multiplying exponents here, I'm going to add exponents, right? Exponent with an exponent is multiply. Multiplying exponents would just simply add my exponents, right? And this here is a quintive function. I have something to the power of 5 here. So 5 here, I'm going to add 6 here, which will give me the 11th degree, right? So this will give me the 11th degree, which would equal my 11 roots. So C here will be our correct answer for this solution. So C here is correct. I'm going to just check D for you as well to ensure that this is the correct answer. D here I have this is 15x to the 9 plus 47x to the 7 plus x cubed plus 5 times x minus 3 here. And as you can see, the highest degree in this first term here is 9, and this degree here is 1, right? So 9 plus 1 here would give me a 10th degree. 10th degree, which would give me actually 10 roots here. So in this case, this would give me 12 roots, this would give me 10 roots, and finally C would give me 11 roots here. So again, this here means that C here is our correct answer because it gives us 11 roots. So this here is our correct answer. C here is our correct answer. And as you can see, the solution also says option C is our correct answer. And as I again stated, a fundamental theorem of algebra states that a polynomial of degree n has n roots counting multiplicity, right? So we're counting the repetition of roots here. So A has 12 roots, like we said here. B also has 12 roots, like we said here. C has 11 roots. And finally, D here would have 10. So this solution here is correct. So solution is correct. Good analysis here. So the solution here is correct. All right, this here is 1. Let's look at number 2 here. It says if the base of a triangle, if the base of a triangle B of a if the base B of a triangle is increasing at a rate of 3 centimeters per second while its height h is decreasing at a rate of 3 centimeters per second, which of the following must be true about the area of a triangle? And it says here, A here says that A is always increasing, A is always decreasing, A is decreasing only when BH. I might have to open up this. Maybe does this give me a? Let me see if this gives me a picture here. Give me a second here. Maybe this would give me a picture. Yeah. So this is a picture of the solution here. So it says if base B of a triangle is increasing at a rate of 3 centimeters per second while its height h is decreasing at a rate of 3 centimeters per second, which of the following must be true about the area of the triangle here? So we're given here, let me see if I can move this over. Yeah, we're given, let's see, we're given, let's write down givens here. So we have base of triangle, so we have some type of triangle here. And it's base here, so the base of the triangle, and it doesn't tell us what triangle it is. So maybe I'll just do I'll just do a right triangle. So here the base here is increasing by a factor of 3 centimeters a second, while its height is decreasing by a height equals minus 3 centimeters a second here. Which of the following must be true about, and we care about the area of the triangle here. The area of a triangle, which is half BH, right? Half of base times height here. And it's saying here, it gives us here A is increasing, A is decreasing, A is increasing only when B is less than H, A is decreasing only when B is greater than H, and E remains constant here. So I'm just going to look at the solution here, and it says that for an area of triangle here, differentiating with respect to time, if B is greater than H, then area will decrease to time. Hence, option D here is the correct answer. So they're saying that they can differentiate this kind of function in respect to time here. So I would have to basically do something like this. I would have to take the area. So I can basically plug this in, right? I can say area here equals half of base here. I can say it's 3 centimeters per second times negative 3 centimeters per second here. And I have to figure out some type of formula here in order for us to differentiate this equation. So it says here, if I'm differentiating with respect to time, but I have to create, the student didn't actually create a formula or a solution here that would actually let me figure out what that formula is in terms of in respect to time here. So let me see if I can figure this out here. So it says increasing on a rate, decreasing on a rate of centimeters per second, and I care about the area of the triangle. So I would have to basically figure out some type of formula that has to relate these two terms together in respect to time here. So I would have to do maybe area over time here. A at t would equal, or I could keep the time constant here and maybe get rid of the t here. So if I take a constant time, let's say maybe 10 seconds, we can say here, maybe let's take here at t equals 10 seconds, what would my what would my values be here? So if t equals 10 seconds here, then my base here would be 30 centimeters. And my height would be negative 30 centimeters here, right? And you would get a value of, let's see, 15 times negative 30, which could negative 450 centimeters squared here. So this would give me a negative area, which doesn't really make sense here, because again, this is simply just the rate at which it decreases here. So it says here, the student picked D as the answer. So it says here, if B is greater than H, if base is greater than H, then area will decrease with respect to time. So if base is greater than the height here, then area will decrease with respect into time. Okay, so therefore, hence D is the correct solution. So I'm gonna visualize this and say if B is less than H here. So if B here, let me erase this here. If our base is greater than our height, let's say if our base here is, let's put 10 here, let's put like a 5 here maybe, this would be centimeters. We're just kind of throwing out numbers. If 10 here is greater than height here, area will decrease with respect to time. And this solution here is correct because it's saying, again, as my height decreases, my base increases, right? So, and again, depending on how fast, again, it's how fast it's decreasing. It's 3 centimeters and negative 3 centimeters, so it's actually the same rate of decrease here. But my base will always start slightly higher, and my height will start slightly smaller, right? So again, if I were to solve this equation here, A equals half BH, and with these two numbers here, so A equals half BH, and A would equal half times the base here, which is 10 times the height here. This would give me 25 centimeters squared. However, if I flipped it, and if I said base is 5 and the height is 10, I would get the actually exact same height here. But depending on the rate at which it decreases, area will also decrease in perspective time. So in this case, I'm going to write here solution here. Solution here is correct, but no explanation is given as to differentiating with respect to time. All right, that's number 2. Let's look at number 3 here. This is what is the inverse of the function? So I give f of x equals, this is 2x minus 10. And close this guy here. 2x minus 10 here, and it says here I'm going to find the inverse, right? So again, if I want to find what f of negative 1 of x here. And if I were to find the inverse, what I would simply do is I would change this to y. So f of x is now y, so 2x minus y. I'm going to have to swap the x and the y term. So this y would become x, and this x would become y here. So I have 2x, x equals 2y minus 10, and then I would basically use algebra to figure out what my new y here is, or what this y here is. Now this is my new inverted here. So this is the inversion here. So again, I would add 10 to both sides. So I get x plus 10 here. I would get 2y, like so, and then I would divide everything by 2 here. So I would get y would equal x plus 10 divided by 2 here would give me y. So this here would be my solution for this problem. And as you can see, they wrote y equals x plus 10 divided by 2. This solution here is correct. Good analysis here. Okay, that's number 3. Let's look at number 4. It says, how do you find the domain and range of a circle? So I care about domain and range of a circle. So again, with a circle here, I have it's kind of a form, a standard form here, and they wrote this here, right? So this is here. This here is a correct formula for a circle. So a circle has this type of formula, and I'm gonna copy this here because this is the correct guy here. So this equals r squared here. So this here would be an equation of a circle, right? I have x minus h squared plus y minus k squared equals r squared, right? Where h and k here are the center of the circle, and r here is the radius, right? So when I talk about domain and range, maybe I'll plot this as well. I'll sketch it for you as well, if to help you to show graphically what's happening. But if I have some sort of circle here, and I'm saying that the center point here is 0, 0. So again, I'm assuming that h here is 0, and then hk is 0, 0, right? So which means here this radius here is simply just r here, right? So this here is good. And what we're doing here is we're talking about the domain and range of a circle, right? So the domain and range of a circle basically just means domain here depending on where does the function lie in terms of the x-axis. So when we talk about domain here, domain would be obviously x has to xer here because x belongs to a set of real numbers. And what we do is we're going to have some sort of limitation here, right? We have this limitation here and this limitation here. So this here, I guess this would be positive r or some radius, and this here would be negative r, right? So between those 2 points, my function exists here. So I'm going to say between negative r less than or equal to x less than or equal to positive r. And this here would be my restrictions for my my x values here, and the exact same thing for my y values. Right? My y values are also restricted here, right? As you can see, I can draw a line from here to here, and this would be my y value here. But this is also r, and this here is also negative r. So I can say that the range here would then also be, again, y belongs to a set of real numbers, but it's also in between minus r and positive r here. So these two would be my domain or range for my circle here. It's always between the radiuses, or plus or minus the radius here. So again, as you can see, the domain of the circle is r minus r, h plus r, which is kind of what this is, and r minus k and k plus r here. So this here, the solution is correct. Again, it's always between basically from the center point towards where r is. I assume that this center here is 0, 0, but what they did was, depending if the function wasn't at 0, 0, I would have to actually include the h's here. So the domain would be, you can say here, instead of this here it's x is between negative r and r, you can say here it's r minus h, and h plus r here, and h plus r here, which is basically from here to here and here to here. And same with the range here, we can say also for the range, we can say here it's k, we can say r minus k, or k plus r here. And this here would be also correct for depending on where the center of the circle is. So I assume that it was 0, which means it was r here, but it's not always the case that our center point is 0 here. So in terms of my circle here, the domain here was correct, but for a more broader sense of a circle, if it wasn't at 0, 0, then you would use basically these two guys to figure out the domain range of the circle here. So solution here is correct. Solution is correct. Great analysis here. Okay, that's good. So that's number 4. Number 5 is asking which formula can be used to describe the following sequence here. So I have this following sequence. I have negative 3, 3/5, negative 3 over 25, 3 over 125, negative 3 over 625, and I'm given four kind of functions here. So I have here f of x equals negative 3 times 1 over 5, x minus to the power of x minus 1. B here states f of x equals, this is negative 3 times negative 1 over 5, x minus 1. C here is f of x equals negative 1 over 5 times 3, x minus 1. And finally, D here is f of x would equal, this would be negative 1 over 5 times negative 3 over x minus 1 here. So basically what we would do is we actually just sub our formula, sub our function here for all the terms to figure out if x here equals 1 and x equals 2 here, right? So for negative 3 here, I would sub this value in for f of x to figure out my x kind of values here. But if you look at the pattern here, I have negative 3, 3/5, negative 3 over 25, 3 1/25, and negative 3 over 625, right? As you can see, it's negative, positive, negative, positive, negative, which means my signs are changing. Therefore, it has to include some type of negative number in my solution here. And all of these contain a negative solution, which is great. What it also contains here, as you can see, the denominators here are also decreasing by a factor of 5, right? So it's negative 3 and then 3/5 and then 325, 3 over 125, and 6, and then negative 3 times 6 over 25, which means C and D cannot be my answers because my base here is 1/5, right? Again, these are all dividing. I'm taking it to a factor of 1 over 5. So therefore, C and D here are incorrect answers. And we just care about these two answers here. As you can see here, B here would also be my incorrect answer because I have two negatives here instead of one negative here. Two negatives would make it positive here, which means the signs would not change. Therefore, A here is my correct answer. And as they said, B here is my correct answer here. So let me just double check. Did I write this down properly? Negative 3 times negative 1 over 5x to negative 1 here. Sorry, just give me a second here. Let's see how they did it here. So again, they're subbing in the solution here, which is good. 3/5 equals negative 3 times negative 1 over 5. We have a pattern here on the nth term, given the formula. Therefore, B is the correct answer. So let me just check A and B here actually for my sake here, just to make sure we got the correct answer. So I'm going to I'll sub in for B first actually and see what they're doing here. So B here, I have negative 3 equals negative 3 times negative 1 over 5, x minus 1. What we can do is we can divide both sides by negative 3 here to get this is 1 is negative 1 over 5 times x minus 1 here. We could take the log of both sides to bring the x minus 1 down. Or what we can do is we can actually just do the first term. The first term, we can actually, instead of doing this here and solving for x here, I'm going to assume that the x is linear. It has to increase linearly from 0, 1, and then so forth, right? So let me do, the first term here would be 1. If x here equals 1, I guess I'm doing this for B. If x equals 1 in this case, I would have negative 1 over 5 here to the power of 0, which was equals 1. So therefore, this term would equal negative 3. So this here is correct. If I did the same thing for this one here, if I put 1 here, 1/5 to the power of 0 is again negative 1. Sorry, it would be 1/5. And then I would also have negative 3. Would I have negative 3 as my value? So here is x equals 1. 1/5 to the power of 0 is 1 here, and this would also equal negative 3. This one would be positive 3 actually. Hold up. So B is actually not the correct answer here. So this solution here is wrong. And the reason why is that if they plugged in x equals 1 here, I can do negative 1 over 5 to the power of 1 minus 1 is 0. Here would give me, oh no, it still give me 1 here. So this is still negative 3 actually. So actually this is still correct. I forgot that anything to the power of 0 is simply 1. So that's my fault here. So, which means these two solutions are correct. So that I would have to basically move on to x equals 2 to figure out whether A is correct or B is correct here. So x equals 2 would give me negative 3 times 1/5 to the power of 2 minus 1 here. Negative 3 times 1/5 to the power of 1 here. And then we get negative 3 times 1/5, so it would be negative 3 over 5 instead of positive 3 over 5 here. So which means A here is wrong and B here is correct. So this is my fault, sorry. So A here is wrong and B here is correct here. So simply if I subbed in 2 here, I would get 3/5 and not negative 3/5, because this would give me negative 3/5, which is not in the series here. Whereas if I plugged in 2 minus 1 here, negative 3 would give me negative 1 over 5 to the power of 1, which is simply, this would actually be negative 3 times negative 1 over 5, which would give me positive 3/5 here, which does belong to my series here. So B here is the correct answer. My fault. Sorry about this. So their solution here is correct. Is correct. Good analysis here. So it's 5. Let's look at 6 here. So it says here, suppose W and T vary inversely and T equals 1/6 when W equals 7. Write a function that models the inverse variation and find T when W equals 9. So it says here, is this question 6? Yeah. Suppose W and T varies inversely, right? So I can say that W here has it's inversely proportional to T, and when T equals 1/6, W equals 7 here. So when I say W is inversely to T, this here just means proportional. This is a proportional. I can say that W here, if I want to change this proportional equals, has to be K times 1 over T here, and this would be K here is simply just a constant to figure out the how it's proportional, how it's inversely proportional between W and T here. And it says here models that T here equals 1/6 when W equals 7. So basically, I'm solving for the constant first. So I'm going to say W here would equal 7 equals K times 1 over T. Here's 1 over 6, right? 1 over 1 over 6. 7 would equal K over 1 over 1 over 6 is simply just 6 here, and then K would equal, this is 7 over 6 here. So that's my proportionality constant for this kind of equation here, and it's saying write a function that models the inverse variation and find T when W here equals 9. So I have my function here. I have my function here. So it's going to say W here equals 7/6 times 1 over T, and this is going to be my function for the inverse proportion and variation between W and T here. And we were finding T when W equals 9. We can simply just sub in 9 for W here. This will equal 7 over 6 over times 1 over T here. We can divide both sides by 7 over 6 in order for us to get rid of this term here. So basically, instead of multiplying, I'm dividing. So you can say it's 9 here divided by 7 over 6 here equals 1 over T. And pull up my calculator and do this really quickly. 9 divided by 7 over 6 would give me, this is 54 over 7. 54 over 7 equals 1 over T. And finally, what I can do is I can simply just what I could do is I could bring T to the other side, and this would be 54 over 7 times T equals 1. And finally, I can divide both sides by 54 over 7. So T here would give me 7 over 54. And this would be my answer for T here. So T equals 7. I believe they missed up the fraction here would give me T equals 7 over 54 here is my correct answer. So solution here is correct. T here equals 7 over 54. Missing the fraction sign on the answer here. So this solution here is correct. Let's see. This here is 6. We can look at 7. 7 states that what is the next value of 1, I, 2, L, 3, O, and 4 here? So I have this pattern 1, I'll do 1 like this, and then I, and then 2, I'll write I like this, 2, and then L, 3, O, and then 4, and then blank here. And I want to know what my next value here. So again, as you can see, look, if you look at all the numbers here, it's increasing from 1, 2, 3, 4, right? So that's good. And then I have here, leave your letters, right? I have ILO, right? ILO, and then some type of number here. So basically how I would like visualize this again, how they chosen to visualize this here is actually the correct method, right? So again, I have I here. What is the value of I? Or actually, this is L. I think it's L actually. Sorry, this here is L. Actually, no, I think this is I. This is I. Sorry, this here is I. So what letter of what number does it correspond in terms of what's the order of I in the alphabet? So you have A is number 1, B is 2, and then C, D, E, F, G, H, I. I is the 9th letter of the alphabet, right? So I can translate this kind of letter to this would here would equal 9 here. L would be, let's see, A, B, C, D, E, F, G, H, I, J, K. L here would give me the 12th alphabet. L, N, M, O would give me 15. And finally, if it's 15 here, depending on, I'm looking at first differences to find out what letter would belong here, right? So again, if I have the 9th letter and then 12th and then 15th here, I definitely see a pattern here, right? I see a pattern, it's increasing by a factor of 3, right? So if I'm increasing by 3 here, 15 plus 3 here would give me the 18th letter of the alphabet. So after O, so O, P, Q, and then R here would be my solution here. So again, solution here is R. So this solution is correct, right? Because R here is the 18th letter of the alphabet, and this here would be my solution here. And if I wanted to kind of make a formula to figure this out, I would basically say that the first number here, the first numbers would basically follow the formula. This would be simply just be n plus 1. And then where n is basically the step increment for this here. So at 0 it would be 1, at 1 it would be 2, and so on and so forth. And every other one it starts as a letter, right? So if I'm starting at I, it would be I would basically have to denote that I'm starting at I. So I can say that letters here would follow the formula. This would be n plus 9, right? Where n here would be, again, my first step, which is 0. First step is 0. So if I sub in 0 here, 0 plus 9 here is 9. It would correspond to the 9th letter of the alphabet. So these two terms would help me figure out basically this sequence here. So n plus 1 and n plus 9 here. So the solution here is correct. And good analysis here. So that's question 7. This is question 8 here. It's talking about the set of all images of the elements in the domain of the function is called, and then it's a multiple choice question here. So let me see. The set of all images of the elements in the domain of a function here would be, and it says here A here says find the image for given values of domain for the given function of this, where x is A here is, so I have f of x here equals 3x minus 2, where x here equals 0, 1, and 2. And it says form the ordered pairs, and then what is the set of the f of x values called as. So so what I can do is I can simply just plug this in algebraically to solve for the domain and range, right? So I plug in 0 here. F at 0 would be 3 times 0 minus 2. This would give me negative 2, right? 3 times 0 minus 2 is 0 minus 2 is negative 2. I can plug in f of 1, and I would get 3 times 1 minus 2, which would give me 3 minus 2, which would give me 1. And finally, I could plug in 2. F at 2 would be 3 times 2 minus 2, which would give me 4 here, right? So again, this here would be would be my y values for this case. So I can actually plug this into a graph, right? I can actually graphically show you what function we have here for. Again, this would be for those complete sets. So let me see if I can draw this out. Can I draw a straight line? I mean, this is as straight as it's going to go. That's fine. And what we're going to do is I have, again, my points here. My first point is 0 and -2, right? So 0 and -2 here would be something like this. I have a point here. My next point here is 1, 1. So 1, 1 would be maybe somewhere here. And then finally, I'm going to have, my point here is, this is 2 and 4, right? So here's 2. So here would be 4. Maybe a point here. And I'll get a line that looks something like this here. I'll get a line that looks something like that. So that's going to be my graph for this function here. It says, what is the domain of this function? The given function in these intervals, right? So the domain of this function is simply just the x values for this function, right? So the domain, you can say, the domain of the function, so I'll write this down here. Domain of function is basically the x is a set of real numbers, obviously, and we're gonna have to write restrictions to this, right? And x has to be basically between or from, basically from -2, from 0 to 2, right? So this would be I would have to say this here is 0, from 0 to 2 here, and this would be the set of my domain for my real numbers for the domain here. And it says form ordered pairs for the given values calculated above. So again, this here is now B. I do have ordered pairs here. So you can say I have the points here. I have 0, -2. I also have here 1 and 1, and then finally 2 and 4. So these are the set of my ordered pairs. And then finally, C says, what is the set of f of x values card? This would be called the range of the function, right? So the range of the function would be the set values of f of x here, range of f of x. And actually, I can actually solve for the range of f of x because I'm given these numbers here, right? So I'm -2, 1, and 4, and basically it can be anywhere from -2 to 4, right? So I can say the range of the function, if I were to calculate it, the range would be y is the set of real numbers. It has to be between -2 and +4. And this will be my answer for this problem here. So as you can see, it says 7 here. Oh, 0, 1, and 3. Oh, I thought it was 2. Oh, it tricked me. 0, 1, I didn't read the question correctly. Oh, no. So this here is 3. So sorry about this. And this here would be, I thought it was 0, 1, and 2. Sorry. This here would give me 3 here. And this here would be 3, which means this number would be 9 minus 2, which is 7. So this would actually give me a graph that looks something more so something like this. That's 7 here. So it actually extends this graph like so. So look at, so the line is slightly longer here. And it's saying, again, my range here would be basically, it's defined as a set of all y values, actually. So this here, C range is defined as a set of all y values with its image. So this answer here is incorrect here, but all of these solutions are correct. So I'm going to say for this sake, I'm going to say solution is incorrect here, or A and B are correct. However, C states that the range is defined as a set of all x values with its image, when range should be defined as the set of all y values with its image here. So this, I'm going to say solution is incorrect just so we can kind of correct this solution as well. Okay, that's number 8. 9 here states that what is the limit as x approaches infinity of cosine x? So the limit, or the LIM, as x approaches infinity of cosine x, right? Of cos x here. So if you think about this question here, x approaches infinity of cosine x. So let's think about the function here, cos x. And we can actually kind of graph it out here, cos x here. let me do a line. Let me do some lines here, so it makes it actually a bit easier. So I have cos x here, and we all know how to draw cos x, right? So again, cos starts at 1, obviously, and then at 90 degrees drops to 0, and then at 180 degrees it would drop to -1, like so, and then back up to 0, and then back up to 1 here, right? So you get something like this. You get something like this. And this will actually oscillate, right? You get something like that, and then you can extend this, and it keeps going, and so on and so forth, right? So let me just put some values here. So this would be, I'm going to say pi over 2 radians. This is pi, 3 pi over 2, and 2 pi, right? This here would be, it's not exactly at 1, but I'm just graphing here at 2 pi, right? So as x approaches infinity, what is the limit as x approaches infinity here, right? So if I can visualize this graphically, as x approaches infinity, as we go towards infinity here, does cosine actually approach a specific value? In this case, it does not, right? I have no limit as x approaches infinity, right? It doesn't converge to a point. It basically oscillates, right? And if you look at the domain and range here, it's the domain here of x here is xer, because it can go towards infinity in terms of x here, but the y here, the range is limited from between 1 and -1, right? So the range of my cosine function. So the range of my cosine function is yer, but y has to be between -1 and +1 here, right? So it's restricted, and it doesn't converge, and basically oscillates from 1 to -1 every 2 pi, right? So when we're talking about the limit as x approaches infinity of cosine x, there's actually no limit. The limit does not exist here. So this here does not exist. So I'm going to say DNE or does not exist because it does not converge to a specific number. So I can't actually write down a specific number here because it oscillates from 1 to -1 here. So it does not actually approach a specific number. So limit here does not exist. So the answer here, limit does not exist. This is correct. So yes, the cosine function has an oscillating value from between -1 and 1. Therefore, at infinity, it can have any value in between, right? So we do not know. It does not converge to a specific value. We know the range of the value. It can be anywhere from 1 to -1, but there's no exact specific value in which the limit is actually defined as. So again, the answer is limit as x approaches infinity of cos x does not exist. This solution here is correct. Solution is correct. Good analysis here. So that's question 9. Let's look at question 10 here. Question 10 states that, how do you find the exact value of 3 pi over 4? So give me the exact value of sine 3 pi over 4. Pi over 4. So for us to do this, basically, we're going to work in radians. This solution here works in degrees here, so it actually changed its degrees, but that's totally fine. It doesn't really matter where we kind of look at this function here. But if we draw a unit circle, we draw a little unit circle here, we would realize that 3 pi over 4 would be basically between 3 pi over 3 is simply just 3/4 pi, right? So remember, this here is pi over 2. This is pi, 3 pi over 2. This could be 0 or 2 pi, right? So this here would actually belong in quadrant 2, right? This is quadrant 1, 2, 3, and 4. And this here would actually give me some type of angle here, right? So I have this here is sine 3 pi over 4. This here is 3 pi over 4, and we're looking at what is the exact value of 3 pi over 4, right? So what we can do with this one here is we can actually break it down in terms of the identities, right? So we know that sine here, we know from our identity, sine here is pi over 2 plus plus some sort of angle of theta would give me negative sine theta, right? Because again, if you remember our cast rule, this is cosine region here A, this is S, and this is T here, right? Or sorry, this is not a negative number. This is positive here. And in quadrant 2, sine here is positive, right? Sine here is positive here. Obviously, in quadrant 1 and 2, sine are positive. A is all, so all trigonometric ratio is positive. In quadrant 2, only sine is positive. On quadrant 3, only tangent is positive. And quadrant 4, only cosine is positive. If we're right here, where our angle here is in quadrant 2, so therefore it will be a positive value. So this is positive sine x. So if we break this down, we have sine here is pi over 2 plus some sort of angle, right? So we can basically subtract 3 pi over 4 by pi over 2 to figure out what theta is. So we can take 3 pi over 4. Let me do some side work here. This is in blue. So 3 pi over 4 minus pi over 2 would equal, I can change my denominators here to basically 4, and this would give me 2 pi. This would give me pi over 4, right? So sine pi over 4 would be my theta here, would equal sine simply just pi over 4, right? And what's sine pi over 4? Well, we know that through our special triangles, right? So we know that our special triangles would give us our basically our trigonometric ratios and our exact values for the triangle here. So let me just draw out the special triangles for you. So again, they're both right angle triangles, but pi over 4 specifically, I'll draw that out specifically, is the 1, 1 triangle, right? So if I have a right triangle here, and if this is pi over 4, this would be 1, 1, and root 2 here, right? So I'm taking the sine of pi over 4, this would be the opposite over hypotenuse. Obviously, opposite is 1, hypotenuse is root 2, therefore the sine, therefore this is root 2 over 2 here. Sine pi over 4 is root 2 over 2, therefore this function here is also, or this kind of relation here also equals root 2 over 2. So this is equal to sine 45, which is 1 over root 2. So this solution is correct, right? So basically I'm using the Castro, I'm figuring out what angle does this lie on, and then what I can do is I can plug in my trigonometric identities to figure out where it lies, what sine it lies on, and how I can break this angle down into an angle that we know through special triangles. So solution here is correct. Good analysis here. Solution here is correct. And then finally, my last question of the day, number 11, is asking, how do you prove d over dx of secant x equals secant x times tangent x? So prove that, so this is simply a proof, the derivative of secant x equals, this is secant x times tangent x. So how do we prove this? Again, we can't really do anything to the right side here. We're going to do something to the left side here. So I know that derivative of secant x also equals the derivative of 1 over cosine, right? So this 1 over cos x would equal secant x, right? This is simply my that was simply the inverse or the reciprocal trigonometric ratio for this, not the inverse, sorry, the reciprocal trigonometric ratio for cosine, right, is secant x. That's good. We can rewrite secant or cosine x as also equal to the derivative of cos x to the power of -1, right? So this here is to the power of -1. If we're taking anything to the power of -1, it's simply just 1 over that thing as well. And what we can do is now we can actually do our derivative rules, right? We can do the power rule to this, right? So if I have d over dx, if I'm taking the derivative of cosine x here, this would equal, or cosine x to the power of -1. I'm going to maybe continue here. This would equal, I would basically take my power here, and I would basically, I'm subtracting it by 1. So I would have basically, this is cos x to the power of -2, and then times the derivative of the inside here, which is, derivative of cos x is negative sine x, right? Which here is, this is negative sine x here. So this here would be my derivative of the cosine x, and as you can see here, they did a u substitution, which is totally fine here. And this actually, it could make it actually a bit easier here. So maybe I'll write that down for you, and I can figure that out for you. So they basically said that let u equals cos x, so they have d over dx equals u to the power of -1. And then what they're doing here is, this is simply just negative u. They're taking d of du over d. Oh, so they're changing it between basically to d of du here. So sorry, this is d over du. And then basically they have here, this is negative of to the power of -1 equals, I'm bringing the -1 down, and then so this here is I'm bringing the -1 down, so this would be -1 here times u to the power of u squared here, u squared. I believe it's -2 squared actually, because I'm subtracting it by 2 here. So we got negative u squared, right, which is simply -1 times u to the power of -2. So I can then, what I can do is I can plug in my cosine again here, and I would get this here would be this here, and then what they did here, du over dx is derivative of cos x over dx, which is equal to negative sine x, like I did over here. That's good, negative sine x here, and I have -1 divided by cosine x squared. So I have -1 here over cos x squared, which is what I have here, times negative sine x, right? Times negative sine x here. So this here is my derivative of this function here. And then what I'm doing is I'm simply just proving this I didn't know. This will equal secant x times some sine x, right? So I can basically, these negatives cancel out. So I have sine x over cosine x squared. Or I can say it's actually cosine x squared like this. And this here, again, sine over cosine is tangent, right? So I can take out a sine and a cosine here, which is tangent x times, and then this is simply just 1 over cosine here. And this here would equal tangent x times secant x here. So this here will be my solution for this problem here. I believe that I think I actually, no, I didn't actually, I don't think I did anything wrong here, because this here, instead of they did a u substitution here, this derivative is also correct here, right? Because I have here, this is negative, I forgot to take the -1 down actually. The -1 down is my fault, because I forgot to bring this guy down when we're taking the derivative here. But if I'm -1 here over cos squared x times negative sine x, and this would be basically the exact same solution as this guy here. So it's the same steps when we're going towards here. So this here is the correct solution. Again, this here is also the correct solution. They decided to do a u substitution. I just took the derivative of it directly, but it's totally fine. So this here is a good solution analysis here. So the solution here is correct. It's simply just it's a derivative question. It's a derivative of a trigonometric ratio, trigonometric function in this equation, and they also threw an identity at us as well. So basically that's how you would solve this problem. All right, so this can come to my end of my video here. Again, thank you so much for watching my stream. Again, I stream math from basically Mondays, Wednesdays, and Fridays, and chemistry on Tuesdays and Thursdays, so you can stay tuned for that. Again, thank you so much for watching. If you're participating and you're following along with me, that's great. Thank you so much for that. What we're going to do is tomorrow I'm going to stream some chemistry, and then Friday I'm going to stream some math for you, so you can stay tuned for that. Again, if you want to pause this video, again, these videos are always uploaded to our YouTube channel at oneclass.com/YouTube, so you can check us out there. You can give us a follow or subscribe, and then you'll be able to keep up with the latest videos for these problems here. So, as always, thank you so much for watching. Take care, stay safe, and have a great day. Cheers.